Sirhi, let's move on to the non-invasive gas integrity test.
The first one is the helium gas test. Here's how it works. One of the heat exchanger circuits is sealed, then a vacuum is created using a pump. Or alternatively, instead of a vacuum, pressure is applied. After that, helium or a helium-nitrogen mixture is introduced into the system. To detect leaks, a mass spectrometer leak detector is used. It registers even the smallest concentrations of helium in the surrounding environment. If the device shows elevated helium levels, the exact location of the leak can be identified. This method can be used for both internal and external leak detection. Among its advantages are ultra-sensitivity. It can detect leaks at the molecular level. High precision, capable of identifying even microscopic defects. And safety. Helium is inert and does not react chemically with other materials. As for the disadvantages, the method is quite expensive, requiring costly equipment and a steady supply of helium gas. It's also labor-intensive. The process demands special preparation conditions. The heat exchanger must be empty. In other words, it needs to be drained before testing can begin. Another drawback is low availability. The method is mainly used in high-tech industries. However, it can also be applied in food production facilities. That said, it is most commonly found in aerospace, pharmaceutical, and nuclear industries.
Igor, could you please tell us, while researching this topic, I read that the helium test is considered the most accurate. Is that true? And secondly, is such a level of accuracy actually necessary for food production facilities, for example? And in practice, how often do you actually see the helium method being used?
Well, actually, the helium test is quite common in the food industry, mainly because of its simplicity and accuracy. Of course, we don't really need to detect individual helium molecules or anything that extreme. And although it's true that helium molecules, like hydrogen molecules, are among the smallest in nature, gas test suppliers don't actually claim to detect leaks on a molecular scale. When they talk about the size of cracks that can be detected, they usually mention a realistic range, from about 1 micron to 10 microns on average. That's smaller than what other test methods typically detect, but still far from atomic or angstrom-level dimensions.
Okay, but in your experience, would you say it's used more frequently, or is it still a relatively rare method?
Well, among the companies I've worked with, both hydrogen and helium tests are used quite frequently. In most cases, actually.
All right, thank you very much. And I think we can now move on to the hydrogen test, which, as I understand it, is quite similar in principle to the helium test. The main difference, Sergey, is in the type of gas mixture used for testing, right?
Yes, mostly the gas mixture. And of course, the leak detector will be different. It's specifically designed to detect hydrogen.
Please tell us about this test.
The working principle is the same as with helium. One circuit is filled with the gas and pressurized. A pressure of around 3 to 4 bar is usually enough. Then, the other circuit is connected in a circulation loop with an outlet pipe. This outlet is located on the return side, before the compressor, where overpressure is created, allowing the gas, or air, to exit through this tube. The internal concentration of hydrogen is measured. If there's a leak, hydrogen will enter the opposite circuit and be detected by the leak detector. And when we need to check for external leaks, we simply fill both sections with gas at the same time and then use the leak detector to locate any leaks from the outside. Among the advantages, it offers high precision, capable of detecting even microcracks at levels of 10 to the -6. It's also safe because the gas mixture used is hydrogen combined with nitrogen, which is non-explosive and poses no danger. Another benefit is the speed of diagnostics. It doesn't require lengthy preparation, and there's no need to completely drain water from the heat exchanger before testing. And it's also cost-effective. Hydrogen is cheaper than helium, especially when compared to the helium method. Plus, the equipment used is simpler and less expensive. As for the disadvantages, specialized equipment is required, namely a hydrogen detector, which is quite expensive. Finally, it's not suitable for heavily contaminated heat exchangers, as the presence of foreign gases may lead to false readings.
Thank you, Sergey. Igor, could you please tell us about the hydrogen method? As I understand it, in this case, we use a gas mixture, right? Since pure hydrogen is flammable, we can't use more than 10% in the test mixture. The critical concentration is around 14%. Above that, the gas becomes potentially explosive. So the question is, how does this method compare in terms of leak detection performance and accuracy when testing heat exchanger integrity?
Well, the fact that we use a hydrogen-nitrogen mixture is both an advantage and a drawback. The drawback is that the hydrogen concentration in the final mixture is reduced, from 100% down to 5 or 10%. Accordingly, the detection sensitivity also decreases, since we're detecting hydrogen specifically, not the mixture as a whole. But the advantage is that nitrogen has a much higher solubility in water. This means there's no need to drain the heat exchanger before performing the hydrogen-nitrogen test.
Sergey, could you please tell us, if someone at a facility wants to perform this test on their own, what kind of preparation is required? And in your opinion, is it better to perform this test, or the helium test, for example, in-house by purchasing the necessary equipment, or is it more reasonable to bring in an external organization? From the perspective of implementation.
From a process standpoint, the heat exchanger must be cleaned after a CIP cycle. That's essential. It has to be cleaned before testing. That's the main organizational requirement. As for the rest, it depends. If a specialized company is hired, they handle everything. But if the test is to be performed in-house, yes, it's possible, but only if you have the proper specialized equipment. Personally, I believe this task is better left to professionals, those who've been doing it for years and have tested many heat exchangers. They know how to conduct the test properly and get the most accurate results.
It's also economically justified because the detection equipment is expensive. If you only use it once a year, it will take a long time to pay off.
Igor, have you ever come across companies that perform gas tests, helium or hydrogen, on their own? Does it actually make sense to do that in practice?
No, I haven't come across that. But it's possible that some companies offer rental services for measurement equipment along with staff training. But I personally haven't worked with any of them.
Okay. And actually, a question recently came up during a conversation with one of my colleagues in the food industry. When performing a gas leak test, Igor, this one's for you. If a factory performs the test internally, doesn't that create a potential conflict of interest? For example, the technical team might be using equipment that isn't fully sealed, and a test that could reveal that might conflict with their KPIs or internal reporting goals. From the standpoint of test integrity and unbiased results, do you think such testing should always be carried out by an independent third-party contractor, or is it acceptable to keep it in-house? What's your take on that?
Well, of course, if the test is carried out by an independent organization that has no prior knowledge of the equipment, it will approach the task more objectively. That's clear and unquestionable. However, if management decides to perform the test using internal resources, then this issue also needs to be addressed at the management level. For example, the test could be carried out by a commission, or some other mechanisms could be implemented to ensure greater objectivity.
Thank you.